Hi everyone. I'm here to talk about a project that is very dear to my heart, and I always try to push it, and we are always welcoming contributors. So this is me speaking out to everyone, and this is a totally open source project, so try not to mind the NVIDIA logos everywhere, but this is a Kubernetes 6 project I will be talking about, and I've been caring about this project since many employers ago. So this is just another employer that is paying me to maintain this project. So this is why I care so much about it. The QR code will tell you to the GitHub webpage, so if you want to see it. And the talk itself is streamline the cluster with automated node levels. So today I will be talking about automating things, automating operations. So if you are here, I guess you care about SRE and you care about platform engineering because you are in charge of heterogeneous clusters or like big clusters are your company and you need easier or better ways to automate how you route your deployments, right? So this is a phrase that I care about a lot, and I always try to put it when I'm talking about automating things. And why I want to talk about this project specifically? It's like Kubernetes was this promise that everything was going to be abstracted from us, right? Like, oh, you can run containers in your laptop. Now Kubernetes is going to abstract it even more, and you won't even care about infrastructure, and you will just deploy the pod, and Kubernetes will magically allocate the pod where it will run, right? We are still very, very far from that, right? Like, still we need to tell Kubernetes where, and how node selectors, and we have resource limits to tell Kubernetes how to schedule our pods. So I feel like we are still starting this journey. We are now discussing moving from device plugins to DRAs and things like that because it's still really hard to tell Kubernetes where to schedule our pods. So this project is here to help us. Who am I? A very quick announcement of myself is I've been working in the container industry for 10 years already. I started working mostly for containers for HPC and academia, so that's my first employer. And all the way down to NVIDIA, I'm now working in Kubernetes and contributing to Kubernetes, making Kubernetes easier and better for high-performance computing deployments and advanced deployments like scientific deployments, academia, physics, chemistry, and now, of course, AI. So I will be talking about a project that is called the Node Feature Discovery and all the things that it enables to you, right? So tell me if you want to contribute. Please, we have many issues and things that we need to work on. But what is NFD, right? Like, this is the first book that really made me laugh when I was reading it. So I kind of like fall in love of The Hobbit. And this is why I like to match The Hobbit to NFD, because it's a project that I really care about. And it's a project that allows you to replicate the conversation between The Hobbit and Smaug when they start leveling themselves. Like, I am. NFD allows a Kubernetes cluster to label itself via many CRDs that I will be showing to you today, right? It's a Kubernetes 6 project. It receives contribution mostly from Red Hat, NVIDIA, Intel, and from time to time from cloud providers. It is composed by the NFD master, the NFD worker, and two kind of like optional daemon sets, that is the topology updater and the garbage collector. The topology updater, I won't be talking about it today, but it's something that is becoming more and more important, and nowadays with AI deployments, is because it will expose some custom resources in your cluster that will allow you to do topology-aware scheduling. So if you care about like ultra optimization of your scheduling by doing topology-aware scheduling, we are in touch with the SIG node and SIG scheduling, and this CR was developed in collaboration with SIG node and SIG scheduling to allow users to do topology-aware scheduling. So only deployed if you really care about that. But really, NFD is one NFD master, there is a deployment, and one NFD worker daemon set that will run a worker on every node of your cluster. How it looks like, what is the core API of NFD? The core API of an NFD is called a node feature. So NFD, the NFD worker, will create a node feature for each node in your cluster. So once you deploy NFD, you will be able to do kubectl get no feature, and you will get a no feature CR for each node in your cluster, exposing every feature that you have in every node, right? And then this becomes very important, because nowadays with AI deployments, you end up having heterogeneous clusters where you have nodes with GPUs, nodes without GPUs, node with big GPUs, node with smaller GPUs, or let's call it expensive GPUs and cheaper GPUs, right? And you want to know where they are. And not just cheaper or expensive GPUs, but I work very closely. So this project also enables, for those that know it, the confidential computing project and the confidential computing operator. NFD enables the operator to allocate where you can run confidential computing, right? This project will find where, like which nodes you have that have the new Intel and AMD CPUs that allow you to do the confidential computing, right? So all of that will be exposed here as features, and what it says now here flags is because it even will expose you the kernel flags, right? Like it will show you everything, like this node, the kernel is using these flags. It's crazy enough to tell you if the server has USB entries and if the USB entry is being used or not, right? Like it will show you everything about your server, from the hardware level to the software level, right? It will tell you, oh, it is Ubuntu 22, running kernel X. So it will tell you everything about each node in your cluster. But what you end up having, right? Like you end up with this. When you do a kubectl describe node, you end up with a huge list of labels that tells you everything. I don't know if you can read here, but it's telling you like CPU model family 23. What that means? Like only if you are like a very Intel or AMD person, you will understand what that means, but it tells you anything, like from the kernel version, from the operating system version, to like what does your CPU support? If your CPU supports SVM, do you know what that is? So do you care about that? So we developed how to automate which labels you want to expose, right? So you don't end up having this, so you can just tell NFD like, oh, I only care about this and these specific labels, just don't tell me about the rest. So the first thing about automated node labels is when a cluster is so big, right? Like we're talking here about when we hear about hundreds of thousands of node deployments, and you cannot manually go node by node, kind of like trimming down the labels that NFD is creating, right? So it's very similar. I really love Small when he's like labeling himself and no one is telling him to do so. And how does that look? So no feature rule. So we can set rules to tell NFD like, okay, only create labels for the kernel or for the kernel config, and we can even do mix matching, right? We can say like, if you find a node with this, and this feature, create a specific label, right? Like you can create label names that are not default to NFD. So NFD by default has some label naming schema, but you can create custom labels that you can set by this no feature rule, right? For example, we at NVIDIA, we use the no feature rule to detect on which nodes you are running GPUs and which type of GPU based on the PCI card. So we have a list of PCI cards, and we then read the PCI card number, and we say like, oh, this is a A100, this is a H100. Then we will go and create a nvidia.com/GPU type equals some GPU, right? And we do that using the no feature rule. So if you are deploying the GPU operator these days, know that you are deploying NFD and that you are deploying many no feature and no feature rules in your cluster. And this is basically how it works. We also, knowing that we are painting your cluster with labels and annotations everywhere, at some point we were like, okay, what if using labels we can tell people, do not come to this node, right? Like, as the gate before getting to a smoke is like, only the word it shall pass. So what if we can set taints based on the specific features of my node? Again, we can go back to no feature rule. So it's the same CRD, no need to deploy another CRD, the same CRD. And instead of saying create a label if you find X feature in my node, you can say create a taint on a node if that node has some feature, right? So you can create a specific taint with a custom names that you define, and this way you can kind of like isolate special nodes in your cluster, right? Let's say your company makes some investments and buys some couple of Blackwell GPUs, and you only want to use those Blackwell GPUs for like very specific things. So you can simply tell NFD, hey, whenever you find those Blackwell nodes, just create some taints on them because I'm going to taint them and only use them for specific projects. Or you can, as well, it goes to all the features in your node. You can tell NFD, hey, create a taint on a node that somehow got a USB plug-in, right? Because security reasons, right? So you can tell NFD, whenever a server in my server rack gets a USB plug-in, taint that node and drain it, because something is happening on that node. Like you can do that with NFD. And and it enables taints via automation, just reading labels and reading annotations. Also, extended resources. Something that we care now is tokens. Right? Tokens is the word when you're talking about AI. But what if you need to control some dynamic and static tokens in a node? Talking about anything. Going back to like the initial or the inspiration for creating this extended resources feature came from the confidential computing project. Turns out, I'm not an expert on the topic, but turns out for every specific Intel or AMD CPU that provides confidential computing, each container that you deploy on this CPU consumes some tokens that you then use those tokens to run the confidential computing on the CPU itself. So those tokens start to run out until they run out, and you need to do some things. I'm not an expert in confidential computing, but I'm an expert in NFD. So we developed the extended resources where you can set dynamic features, and NFD is basically checking on the node for what, like you can configure this. What do you want to be checking, right? So in the case of confidential computing, we start checking the tokens of Intel or the tokens of AMD, and we start exposing those in the node feature, not in the node feature root, but in the node feature that I talked in the past. And then when you do like kubectl describe node, in the section where you get the allocatable and capacity of the node, you will read those tokens that you are running out of, right? So you can also expose this via NFD. So this is how NFD is helping projects like the confidential computing project to expose which nodes have those tokens and if you're running out of those tokens or not. And this is dynamic, and this is customizable and extensible to any idea, right? Like, let's say in your node you have a file that runs out, and you need to be checking if the file is getting clean or not by some project that you have. Then NFD can be exposing how many of X do you have in your node, and since it is exposing it on the allocatable and capacity of the node, then you can use the Kubernetes scheduler to make those allocation decisions. So NFD helps you automate that as well. Another CRD that now NFD is exposing is the Node Feature Group API. This CRD was just approved before KubeCon Paris, and it's basically NFD way of saying that we also want to play in the multi-cluster ecosystem. So now I participated in the Cluster Inventory API that also got approved, that is now a Kubernetes SIGs, and it's a new API that is coming out of SIG multi-cluster. But this Cluster Inventory API needed something cluster level, so it could map, like, tell me everything about the cluster in a very abstracted way. So we created a Node Feature Group. The Node Feature Group API is a very simple API that follows the similarity of the Node Feature rules, but is now the Node Feature Group CRD. And you can basically create node pools or node lists based on features, right? So you can tell NFD, like, oh, create me a node pool of all the nodes that have this specific feature. Because then you can use this list of nodes, and using a custom controller, schedule specific custom logics on top of just those nodes, right? So this, the idea of this API is to be used to feed the cluster inventory API when you are managing, as I put here in the example, topics like Hyperchief or our KCP or OCM or Karmada or any other multi-cluster solution that is out there. So if you know that in X cluster you have a pool of nodes with X feature and a pool of nodes with Y feature, then you can build custom logic to a schedule on top of those specific node pools. So this is another CRD that NFD exposes. And with that, this is kind of like a brief introduction to everything that is NFD. And thank you. And again, if there is no QR code here, this is the QR code to NFD, and I'm open to questions.
Thanks for the talk. So when you mentioned extended resources, I was wondering how those relate to like resource managed by device plugins, because they have like similar annotations.
Yeah, in our official documentation page, we have like a big warning, like this is not a replacement for the device plugin, right? Like as I said, NFD is deployed when you deploy the GPU operator of NVIDIA, and the GPU operator deploys a device plugin, right? So it's like you still need a device plugin to do what a device plugin does. This just reports back resources or features that are dynamic, that are changing over time. But this is not going to configure your container runtime as a device plugin does, right? Like to tell the runtime, oh, you need to mount these files and things like that. This will only constantly ping your node and see if that resource is running out or not, right? And as the example that I put here, I like the dynamic, the kernel version. Sometimes, by mistake or something, you run an update on a cluster, and half of the cluster changes the kernel version. This will allow you to see that, right? Like this will allow you, this will show you if the kernel version has changed.
So you mentioned that the NFD also checks like the Linux version of the node, but how far does it go down? Can I go if a certain tool is running in Linux, if the, I don't know, in the end, if a certain file exists on the machine?
Yes.
Okay.
Yeah, you can. So by default, this is like the NFD deploy, like a Helm install NFD. This is what you will get. This is the default. But NFD actually knows more about your system than this. It's just that if we advertise all the things that we know from your node, it will break the ITC, because ITC only supports like 1.4 megabytes or something. So we decided to go for a default set and just open it with the node feature, and node feature rule API, open it to the people like, oh, request whatever. But this node feature, this node feature CR weighs more than 1.4 megabytes. That is what ITC supports for labels. So that's why we are doing that way.
But you could, for example, decide, okay, this is a developer node where there is certain tooling installed already, pre-installed, which then other nodes are for production, these kind of things.
Yeah, and also since this node feature is a CI, it's a custom resource, not a custom resource definition, you can have vendors modify this just by configuring a custom controller in this with the specific service account that has permissions to modify the node feature of a node, right? So what we do from NVIDIA, for example, is that we deploy a daemon set that is called the GPU feature discovery, and it's a daemon set, and it will be installing all the nodes. And on the nodes that it detects a GPU, it will go and modify the node feature and put like an extra entry saying like this is a GPU node, right? That's what we do as NVIDIA. So you could do the same, right? Like you can have a custom daemon set that goes in all the nodes, and on the nodes that it detects, whatever you want to detect, then you go and modify the node feature for that node. As you can see there in metadata, name vendor features for node 1, right? So you will have one for each node. And then you can have a custom controller to expose custom labels based on whatever you want to find.
Hey, hi. Thanks for the talk. I was just curious about the Taints addition of the Taints flag, which you described in a few slides before.
Oh, the taints?
Yeah. So, if I understood it, it adds Taints to the nodes?
Yes.
But then I'm just curious. Then for the pods which are already running for the application,
It will drain the node.
it'll drain the node. Okay. And then the application has to then be aware that this is the taint being added. So how do you? So that's something which the application person has to know then, I feel.
Yeah, I mean, like taints are like, as the previous talk, are like a security thing. When you do a taint on a node, it's for a reason. You want no one to use that node for a business case reason, right? So this is why it's automated, because the idea of NFD is to work on these 1,000 node deployments, and you don't want to. These days, when people do taints, they do it like manually, like one by one, or maybe they have like an Ansible script to find which nodes to taint. But that's why we develop it for NFDs. Like if we know everything about each node, we can then just help you to taint the nodes that you need.
Just to expand on that, that's where my question was coming to. So when the machine, so for example, if you're using machine pools to create the machines itself via cluster API and its providers, you can just specify the taints. So I think this case is specific to when you are just creating the nodes without anything, any labels and taints, and then you start adding them. Okay, sure. But could you expand more on then how are you creating the nodes underneath?
The nodes?
The nodes which get created on the cluster, for example, how are you creating the nodes then?
No. This is on a running cluster. We are working with the copy developers to see if we can do like a reverse NFD. So instead of creating labels for existing nodes, we can create nodes for existing labels. We are exploring that option with the copy developers, because one of them jumped into the Slack channel. So we have official Slack channel for NFD, and they were like, hey, what if we create like a node feature? So we create what if we create the node feature, a node feature, and we put node name blah, and if the node actually doesn't exist, then that will tell copy to create that node based on the labels that you fake it. But that will come maybe like in a year from now. That conversation just started.
Thanks.
Yeah, hi. Thanks for your talk. It was really insightful because we're using right now the NVIDIA GPU operator, and we deployed the NFD operator, and I never knew what it was and what it can do.
Welcome.
So there was like a great insight. So because I think I have a more question to the feature rule. So because right now what we are doing is we setting already labels on the node pools technically. So for example, to determine which traffic class it is. So because we have different GPU types, so we're using T4s, so there could be nodes like with 2 accelerators or 4 accelerators. So by that also the traffic class decides. So traffic class is the t-shirt size, so like an own label in all clusters. And when I would now use a feature rule, so I don't need to label my nodes anymore, so I can deploy only the feature rule and it will happen then dynamically, if I understand correctly, right?
Yeah.
Yeah, that's true. So then we will implement.
Yeah,
this.
and in our, again, here, we have all the documentation and examples on like how crazy can you go with no feature rules, because it has like a name matching or even like a expression like values, like if it exists or not, things like that on any type of features.
Yeah.
So, actually, we are using it like if you inspect the GPU operator GitHub repository, there is a folder, and in the Helm deployments folder, there is a no feature rule for Grace and Grace Hopper features. We are advertising them using the no feature rule. So instead of using the GPU feature discovery, we are using the no feature rule to advertise the features.
Well.
So you can find kind of like an example there.
Yeah.
That's it.